Yeah, if I leave it at the default value, of course, immediately I make changes here, is going to affect all the way to the front. So what I needed to do as an attacker or someone with ulterior motive, when you make changes in the previous block, the next thing we do is to go to all other blocks, the subsequent blocks, and remind them. But one thing you need to note is this: how much power do you really have, okay, to begin to recalculate the nonce value for you to be able to remind this entire thing. But is it possible? The answer is yes, it is absolutely possible. You have a solution to that problem, we have a solution to, and we discuss that solution now after your question. Please, questions, please. Questions? Question? Oh, okay. No question, I assume. Okay, so let's look at how we normally secure this behavior of someone with ulterior motives to basically want to change, modify the value, manipulate the value, and recompute the hash of each block to ensure that that modification is consistent across the uh, the network. So we have this concept of distributed. You have this concept of distributed. So this is where we have multiple pairs of that blockchain. So you have the blocks, okay? You have the blocks of transactions already forming a blockchain. Then the next thing that will be put into a specific pair will be something like a pair A. Then the next is to have another pair of the same thing. So you can see this one here. The same values you have in the first pair is the same value you will be having in the second pair. You can have the third one as well. You have the same value for the third one as well, depending on the way you structure your blockchain network. You can have up to like five, you can have up to like the way depending on the way you structure your block, the blockchain network. So which means the copy you have under pair A is the same copy you have under pair B, is the same copy number of blocks, the information you have under pairs. So what happens is this: you join a specific pair. Whenever your system is connected to a blockchain, a specific blockchain network, you are joining a specific pair. So if we modify the value, let's say I modify this value, and you are able to mine that value, you can see the hash has changed already. Let's say from my own computer now, I've been able to modify this value, and I want to remind the value. I've been able to remind the value. Immediately my system tries to rejoin the network, then it will compare because I joined that specific pair, then it will compare that pair, okay, where I change the value. I think I changed the value under 5, fifth one. It will compare it with the hash. The hash is expected to be 000E4B9. But your own hash is D9198. Okay, okay, I don't want to use that one. Why not go to another pair and confirm? So which one? What about the hash of this one? So you can see the hash of this one is the same thing as the hash of this one. So if those two pairs are having the same hash, it means something is definitely wrong with this specific pair. And later they discover that, oh, you're having a different value from what we are having under our own pair section, and they will throw that specific system out of the net. They will throw that specific system out of the network. So that means you have to rejoin another peer, okay? Or you modify whatever things you have modified, you rejoin the network and you will be accepted. So this is the way we normally ensure that as long as you're on the network, you will not be able to modify any information at all on the network for any reason. So, and if you modify from your own end, there's a mechanism, this distributed network mechanism, also known as sharding. So this um, mechanism ensures that we can check as multiple peers as possible to ensure that any peer that is trying to sync with the network has the correct blocks information as the other peers. If your own information is different from the other peers, of course, such specific user will be thrown out of network. So this is not determined by anybody. These are set of rules already, executing on the blockchain network itself. And they are set of rules, they are programs. You can use Java, you can use JavaScript, you can use Python to put all these things together. And you can also come up with your own blockchain network. As long as you once have a very fantastic background knowledge of the different pieces of some of these things, you can create your own blockchain network and people can start using your own blockchain. Questions, please? Questions? Questions? So let's see how far we've been able to achieve today. Yes, questions, please.
Hello, sir.
Hello, Mr. Kano, please go
You,
ahead, sir.
yeah, you mean that an individual, just an individual, can have a blockchain network?
Yes, you can. You can set it up yourself.
Is that so?
Yes, you can.
That's good. It's an excellent one.
Yeah, you can set it up yourself. Yes. Questions, please? Okay, let's see what we've been able to cover. We see of course, we have not seen the origin because I think I mentioned something about Satoshi Nakamoto, the introduction, the blockchain mining, the distributed ledger, and distributed network. That is the one we just completed now. Tomorrow we'll look at how are these accounts. So, for instance, I have one Bitcoin, I have two Bitcoin, I have three Bitcoin. How are these value kept on the blockchain? Since there is no central control, how exactly are we really storing these values? And so we have two models. We have unspent transaction output model, and we have account balance model. For the Bitcoin network, it uses UTXO, while the Ethereum network uses account balance model. So we look at the difference between the two and also look at the security, the privacy, the ecosystems, and the rest. But before that, tomorrow, if we have time, please let's check these two websites, most especially the uh, Bitcoin network, the Explorer. This is the Bitcoin. If you go to blockchain.com/explorer, you can um, pull all this information that we just discussed just now on a live Bitcoin network. So if you look at it closely, you see the current block height. Okay, we mentioned that there's a block number, block 1, 2, 3, 5. So the current one, real live right now, is 752,712.